Okay, Unit 3, Lesson 6. More about factoring. We're going to review some of the stuff we already know, and then move on to a couple more new things. So, the most important thing to always remember, which we've stressed over and over, is you have to remember to always take out the GCF, the greatest common factor. Always. Always look for that. If nothing else, it will just make life easier. You have smaller numbers to deal with when you're factoring, guessing and checking, whatever. So number one, we're going to do the GCF. And I'm going to look and see that all the numbers are multiple to 5, so I can pull out 5. And I'm going to look for the common variables and look for the smallest exponent. So I have x cubed, x squared, and x to the 1. I'm going to take out x to the 1. I have a y cubed only in one spot, so there's nothing of y's in common. Now I divide. 5 divided by 5 is 1. X to the third divided by x to the 1 is x squared. 3 minus 1 is 2. Plus 10 divided by 5 is 2. X squared divided by x1 is x to the first. And the y cubed just tags along. And then 5x divided by itself. Here's where people a lot of times want to just stop and put parentheses. Well, you don't do that. You have to account for the division of 5x divided by itself is plus 1. You need to have that spot. You can't just throw it away. Okay, so that's covering the GCF. Now we're going to go back to this table in the middle just to review what we know, and then move on to a couple of new things. So the difference of two squares. A squared minus b squared. That always factors into two parentheses, two binomials. One is always going to be positive, one's going to be negative. And the reason that is because the middle term drops out on a difference of two squares. So we end up with a plus b times a minus b. Now let's go back to number 2. We're going to kind of bounce back and forth here. So we look at 4, x to the 4, 81, and y squared. They have something in common. They are all perfect squares. So all we do is take the square root of 4, 2. Now remember, we talked about this before, when exponents are even numbers, we just divide into 2. So x to the 4th, we're going to put x squared here and x squared here. Because x squared times x squared is x to the 4th. Now remember, 1 is going to be plus, 1 is going to be minus. Now we take the square root of 81. And now we take the square root of y squared, which is just one single y. Or y to the 1. Which is also half of 2. So once again, whenever they're even exponents, we just divide by 2. After we learned some difference of two squares, we moved on to sum of two squares, which was incorporating the imaginary number I, imaginary value I. So if you remember, this breaks down very close to the difference of two squares. You have two parentheses, one with a plus, one with a minus. The only thing that's different is I on the end. We have to have that so that the last term, which will be multiplied right now, positive times negative, last times last, we'll get a negative. But we need it to be positive. Well, think about it. When we multiply I times I, it's I squared, which is negative 1, which turns that last term positive. So once again, we have two parentheses, one plus, one minus. Take the square root of 25, 5. Take the square root of x to the 4th, cut it in half, x squared. Take the square root of 49, 7. Now if we multiplied it just the way it is right now, it would be the difference of two squares. And we get 25 x to the 4th minus 49. But we don't want that. We want it to be positive, so we have to add the i's on the end. Okay, now the new stuff. We're going to do the difference of two cubes and the sum of two cubes. And if you notice, you have this nice handy dandy chart down here, which is going to help with factoring our numbers. So the formula for a cubed minus b cubed, you have to remember the acronym SOAP. And that stands for, let's see where I can put that. How about up here? Same, opposite, and always positive. S-O-A-P. There we go. If you want to write it somewhere else, that's fine. So, first thing we're going to do is we're going to write the cube root A minus B. Okay? And we're going to use the same sign. So since this is a difference, we're going to do a difference first. Now, we square A. A squared. Now, remember, so we just had same. Now we're going to do opposite. Then we multiply A times B. And then the last term is always positive. So plus B squared. We square that. Let's see if it was some real actual numbers. X cubed minus 8. Well, first off, this is 1x cubed. So we're going to look for the cube root of 1, which is 1. So it's going to be 1x minus, but for the cube root of 8, which is 2. So remember, a minus b right here is the cube root of each of the terms. Now, so that was the same. We're going to take the cube root, or we're going to square a. That's x squared. Now we're going to multiply these two terms. And the SOAP, we're going to do the opposite. Negative 2 times x is negative 2x. We're going to multiply. And then we're going to square the last term. So here we have same, opposite, always positive. So that's factored. Let's try it again. We're going to look for the cube root of 27, which is 3. The cube root of x cubed is x. Same. Cube root of 64 is 4. And the cube root of y cubed is y. Now we go into our trinomial. We're going to square this first item. 3x squared. I want to take 2 steps for this. You can go right to the answer, but I want to take 2 steps. Now, we have same. Now we're going to do opposite. 4 times 3 is 12, and x times y is xy. And then the last is always positive. And we're going to square 4y squared. So that gives us 3x minus 4y times 9x squared plus 12xy plus 16y squared. I know it's a lot. It's a variation of what you already know, but it will come to you. Now let's go over the sum of two cubes. It's going to be the same thing. We're going to use SOAP again. 1 is just 1. Now we're going to square. This time we'll go right to it. Make sure you remember to square the number and the variable. So 5 squared is 25, and then x squared is x squared. There's a squared. Now, opposite, we have our same. Now we have opposite. 1 times 5x is simply 5x. And then we're going to square the last. 1 times 1 is 1. Always positive. Okay, 54 is not on our list. Neither is 2. Not on our list. What do 2 and 54 have in common? They're both multiples of 2. So we have a common factor there of 2. Also, we need to look at our x's. We have x's in both terms. So we take the smallest exponent, and that's what we're going to do to reduce. 54 divided by 2 is 27. X to the fourth divided by x to the fourth is x to the third, plus y cubed. 2x divided by 2x simplifies, cancels 1. Now, we can't throw away the 2x, so it stays out there. But now we're going to do our new pattern. Cube root of 27. Again, is 3. Cube root of x cubed is x. So, same. Cube root of y cubed is y. Now we square a. So 3 times 3 is 9. X times x is x squared. We did same. Now we're going to do opposite. Multiply a times b, which is 3x times y, which is simply 3xy. And now we're going to square the last term. Always positive. And there we go. Like I said, I know it's new, but you'll get used to it. We'll have practice on it tomorrow. Okay, so trinomials. Look for a GCF, easy factoring, or use guess and check or slide and divide, or the AC method if you watch the video. And once again, factoring is not going away. So if you are not comfortable with guess and check, go to the video from Unit 2 called, I believe it was Alternative Factoring Examples or Methods or something like that. But the video is on there. But you're going to have to do more factoring. So, real quickly, let's talk about something we've already done before. X squared minus 5x minus 6. Okay? We know we're going to have two parentheses here. X, 1x is prime, so it's x times x. For the 6, it's either going to be 1 and 6 or 2 and 3. And we need two numbers that differ, that multiply to give us 6, that differ by 5. In this case. Well, 3 times 2 is 6, but 3 minus 2 is 1. So we know it's going to be 6 and 1. We use our smiles to figure out where the positive and negative goes. This is 6. This is 1. I want a negative 5. So that means the 6 has got to be negative and the 1 has got to be positive. Okay? That's what we've done before. What we've also done before, another example before we get to the actual examples, is this. X cubed minus 5x squared minus 6x. Well, look for a GCF. So I'm going to pull out an x, which gives me x squared minus 5x minus 6. Look familiar? Yeah, it should. We just did it. So that's going to end up being this. So now we're just taking it one step further. Now we have x to the 4th. But think about it. Key is that's even. So we're still going to have two parentheses. But instead of x times x, we're going to use x squared times x squared. Really easy. If it was x to the 8th, we do x to the 4th and x to the 4th. If it's x to the 6th, like coming up at number 7, it'll be 3 and 3. Now, our middle term will work out with these x squares. The numbers are going to be the same, 6 and 1. So they're going to be negative and positive. Watch what happens with the inside terms. Negative 6x squared plus 1x squared gives me negative 5x squared. So see how it's really not that different than what we've already done. It's just we have a higher exponent. No big deal. Now, example 7, we also want to make it easier by factoring out the 2. So now, 2 says, we're going to have our 2 parentheses. 2 is a prime number, so it's got to be 2x cubed times 1x cubed. 3 is a prime number, so we know it's got to be 1 and 3. We just got to figure out which way to get 5 left over. Okay? So if I do the 3 here and the 1 here, I get 3 and 2. Well, that's not going to help. So if I put the 3 here and the 1 here, now I get 1 and 6. 6 minus 5 is 1. That's what we want. I need to find out where the signs go. Since I want my 5 positive, I need my 6 to be positive. That comes in here, which makes this negative 1. So once again, it's really not that new. We just have higher exponents at the beginning. But the structure is exactly the same what we've been doing for months. 4 terms. Grouping. We've done this. We know how to do this. We group the first 2, we group the second 2. We take out our GCF. What goes into 5 and 10? 5. What goes into x cubed and x squared? We take the smallest exponent out. Now we divide. 5 divided by 5 is 1. X cubed divided by x squared is x to the 1. X to the first. Minus 10 divided by 5 is 2. And we took out the x squared. X squared divided by itself cancels. What am I going to take out of 3 and 6? A 3. I have to figure out what I want. Remember, we can cheat and go ahead and write this ahead of time. X minus 2. Now we just got to figure out if we want a positive or negative 3 taken out. Well, if I want to do 3 and end up with 1, both positive, I need to divide by a positive 3. Now all I do, since this and this are the same, I hook up these two. 5x squared plus 3 times x minus 2, or 1x minus 2, whatever makes you happy. Okay, next one, I'm going to group those two and group those two, put a little plus in the middle because it was a subtraction. And I'm going to take out what I can. What goes into 16 and 4? 4. X cubed and x squared, I look for the smallest exponent. No y's in common, I'm ready to divide. 16 divided by 4 is 4. X cubed divided by x squared is x to the first. Minus 4 divided by 4 is 1. Don't have to put that. The x squared cancel, leaving me y squared. Next, I know ahead of time that I want 4x minus y squared. I know that. So what do I have to divide negative 28 by to get a positive 4? Well, certainly it's not 7, because that would give me a negative 4. So it needs to be negative 7. Since this and this are the same, I hook up these two. 4x squared minus 7 times 4x minus y squared. And there you go. I'll have plenty of practice on that